Figure 1.3 shows a person bungee jumping from a bridge. The person is attached to a long elastic rope. In 1.5 seconds, the speed of the jumper increases from 0 to 10.5. Calculate her average acceleration during this time. So from the previous video, I taught you to list the variables vertically downwards and then fill in the ones that you have. Fill in the things, put a question mark next to the one that you want, and then leave any other symbols out that you don't need. We have the initial speed because the person starts at 0. We have the final speed, which is 10.5. We have the time taken for this bungee jump, which is 1.5 seconds. And then the variable it requires is the acceleration. So the question mark is on there. So in other words, we don't need distance. Remember, S is distance or displacement. It is not speed. So I need an equation with V, U, A, and T. From the equations in motion, of which there are 4, again, I discussed this in the previous video, the equation I need is V equals U plus AT. Substituting in the numbers that I have, so 10.5 equals 0 plus A times 1.5. So therefore, A equals, to the acceleration of this person, is 7 meters per second squared. At one point during the fall, she reaches her maximum speed. State her acceleration at this point. So the maximum speed is sometimes referred to as the terminal velocity. Now, it's not a trick question. You just need to understand what this phrase means. So at the terminal velocity, or the maximum speed, the downwards force of the object, in this case it's a person falling, is equal to the upwards force of air resistance. So the resultant force is going to be 0. So therefore, if there is no resultant force, the person is moving at constant speed and cannot be speeding up or slowing down. So thus, the acceleration must be 0. Number 2, what can be said about the forces acting on her at this point? Well, like I just explained, so if we call the downwards force her weight, W, is equal to the upwards force F, then W is equal to F. So the forces are equal. On to the second bit now, which I think is actually a little bit more challenging. A person is standing on top of a cliff, throwing stones into the sea below. 800 meters from the point where this person is standing, a Navy ship is having some target practice. So the point at which this person is standing is there. The person finds that if a stone is dropped vertically at the same time as the spurt of smoke from the ship's gun is seen, the stone hits the water at the same time the sound from the gun is heard. Sound travels at 320 meters per second. Calculate the speed at which the stone hits the water. This is 4 marks. It's obviously more thinking to do than the previous bit. So what do I need to do? How do I work this out? Well, I think it would be a good idea to add to the diagram the information that we're given. So 800 meters from the point where the person is standing, a Navy ship is having target practice. So let's actually put that in somewhere random. So there. Then the distance from the ship to the person to the point at which he's standing, we're told, is 800 meters. Then we're told that he drops a stone. So let's do that in blue. And the stone travels vertically downwards and then strikes the ocean at that point, X. And at that point, it strikes the ocean. It says the sound from the gun on the ship can be heard. Therefore, the first thing we have to do is work out how long it has taken that sound wave to travel from the gun to the person's ear, because that will tell us the time taken for the stone to go from this point to this point. In other words, the distance is traveled. The speed of sound is 320 meters per second. We use the equation speed equals distance over time. We know the speed. We know the distance the sound wave has travelled. It's 800 meters because it's travelling from the ship to the person's ear. So let's go ahead and rearrange the equation. So it'll be 800 divided by 320 is 2.5 seconds, which is the same time it takes for the stone to strike the water at that point there. Right, so now we need to work out what the velocity of the stone is just before it hits the water. So again, we turn to the SUVAT method. S-U-V-A-T. The person is holding the stone in their hand. So that means the speed of the stone at the beginning, well, it must be 0. So U is 0. The final speed, V, is the question mark. The acceleration that the stone experiences is the force of gravity. For objects that are dropped vertically, gravity is always 9.8 meters per second squared. Okay, so gravity is 9.8 meters per second squared. That's the acceleration due to gravity. Also 9.8 newtons per kilogram. So if you know the acceleration the object is experiencing, then we can go ahead and work out the remaining parts. So acceleration is 9.8 because that's the force of gravity acting on the object. The time taken to strike is 2.5. And then the vertical distance, which would be S, so this would be S, we don't know. So we can actually strike that with red. We can leave that out. So we need an equation with V, U, A, and T again, which coincidentally is the same as the equation I used the first time. So let's go ahead and work it out. So the speed at which the stone hits the water is about 24.5 meters per second. Right, I hope that question is helpful. I think it's a really difficult one. So if you have any questions or are stuck on any parts, please comment down below and I will try and get back to you as quickly as I can. Otherwise, I will see you in the next one.